Hey, hey, go ahead and open your books to page 84. We're going to finish this lesson. Lesson 6-1. So remember we were talking about Tom hiking a circular trail known as the Juniper Loop. Just a reminder to have your vocab organizer out with you. It'll help you remember things. So question 16 is identify the absolute minimum of the function. So the absolute minimum, remember that's the lowest y value no matter where it occurs. It can be an endpoint, it can be in the middle of the graph. So the absolute minimum here matches your range value. So this is 0, so that's right, my absolute minimum starts at 0. So what does this represent? Well, let's read our y-axis and what it's labeled, or our d-axis, and that's the distance from start. So this is Tom's least distance or lowest distance from start. He is at the starting point of the loop of the trail. Number 17, which is at the top of the next page. In this function, the absolute minimum corresponds to 2 points on the graph. The absolute minimum corresponds to 2 points. What are the 2 points and what do they represent? So if I'm going up and looking, okay, here's one absolute minimum. Here's the second absolute minimum. So let's write those as ordered pairs as points. So the first one is actually our y-intercept. It's 0, 0. That's the absolute minimum as well. And the next one occurs, what's that x value? The greatest time was 165, 0. And what do they represent in this context? They represent Tom's lowest or least distance from the starting point or from the start, which occur at the beginning and end of the hike. And it makes sense that we have 2 absolute minimums, because if you're parking your car and you're getting out and hiking in a circle, you're going to end up back where you started. So it's the beginning and the end of the hike. All right, try questions 18, 19, and 20. And 21. Try them all. 18 through 21. You can do it. Absolute maximum of the function is the highest y value no matter where it occurs. So remember, this matches your range value from question 15. So if I'm looking, the peak or the highest point, it's at 7. And what does this represent? This is Tom's biggest or highest or greatest distance from the start. What points on the graph correspond to the absolute maximum? And what does this mean in the context of Tom's hike? So if I'm looking here, here is our area right here where we're at 7. Okay. So where does this start? Well, let's see. If we draw a line down here, this is 75, and it's a little bit past 75, not quite to 90. So I'm going to say it starts at a time of 80, and it goes to not quite 105, so maybe it ends at like 100. So all the points along the graph from time equals 80 to time equals 100. So 80 minutes to 100 minutes. So what do you think this means? Why do we have a little flat line here, and I actually have another flat line here? What does that mean? What do we think Tom's doing? Well, Tom is probably stopping to rest, sitting down, he's taking a break, resting his feet. Maybe he's drinking water, eating some lunch. Who knows? Maybe he's pooping in the woods. So he's taking a break. He's stopping. He's resting. All right, number 20. Identify any relative minimums. So remember, a relative minimum, we're looking for like a low point or a valley, and this cannot be an end point here. Identify a relative minimum, and it cannot be an end point. This kind of looks like one to me right here. So how many of you wrote down 5? And do we see any relative maximums? Kind of like a high point. It's not an end point, so I'm going to use it. 7. And just a reminder, both of these are not endpoints. So keep drilling it into your head. So hopefully that helps you for your test. All right, question 22. What are the independent and dependent variables for the function representing Tom's hike? Okay, so remember, independent is our input, which is our domain, which is our x values. So if I go back and look, this right here is all of my input, independent variable, x values, domain. So the variable is t, and remember, variable means letter. Okay, so I'm going to abbreviate. Independent would be t. And what does that stand for? T stands for time in minutes. And then your dependent variable, remember, is your output, or it's your y values, or it's your range. Okay, so let's go back and take a look at our graph. And that would be everything on this axis right here. So it's cut off, so if I slide it down, you're going to see that it's a D. Okay, and D stands for distance. So my dependent variable is D, which is our distance from start, and it's in kilometers. So think about that. My distance depends on the time. My distance from start, beginning of the trail where I left my car, depends on how long I've been hiking. Okay, your dependent always depends on the time. Time is independent because you could choose to hike for 15 minutes, 62 minutes, 125 minutes. You get to choose how long. So that would be independent. Question 23. Explain, in your own words, how to determine the maximum and the minimum values by looking at a graph. How do we find minimums and maximums? Well, we need to look up and down vertically at our y values. We look for any highs and lows, right? Any hills and valleys or peaks and valleys on your graph. Highs and lows. So our y values, remember, are vertically up and down. And just remember that relative have to occur within your graph, somewhere in the middle or somewhere in between. They cannot be endpoints. And then absolute minimums and maximums can occur anywhere on the graph. They can be endpoints. They can be in the middle. We're just looking for the absolute lowest point and the absolute highest point. So question 24, is it possible to have more than one absolute max or absolute min? No. If we're looking for the shortest person in our classroom and the tallest person in our classroom, we're going to have one. Or if we're looking for the youngest and the oldest, we're only going to have one. So this would be no. Absolute minimum or maximum cannot be more than one value. So if 0 is the lowest, that's the answer. If 15 is the lowest, that would be the answer. All right, we're done with that lesson.